Artificial intelligence systems that generate visuals when you type a term have amazed the globe for a few years now. Stable Diffusion and DALL-E are two programs that will produce visuals in any style you choose. Today, we're going to discuss Meta's new text-to-image surprises everyone. Recent developments in natural language processing and software that generates images from text input have boosted interest in generative AI models. The most recent research on Chameleon, a transformer-based model that generates cutting-edge text-to-image output and has innovative multimodal AI capabilities, was presented by Meta. For the first time, an autoregressive model has successfully competed on key benchmarks against leading generative diffusion models using Chameleon. Our approach broadens the applicability of autoregressive models, demonstrating their potential to compete with and outperform diffusion models in terms of cost-effectiveness and performance. In 2021, Patrick Esser and colleagues conducted research at Heidelberg University that gave rise to the idea of Codebook, the long-established CNNs, convolutional neural networks, which excels at handling image files, were changed. CNN was taught using an AI program called a Generative Adversarial Network, or GAN, which can produce images to connect aspects of an image, such as edges, with entries in a codebook. Each subsequent word can then be predicted using those indices in a language model like ChatGPT. High-resolution photos are transformed into sequences of index predictions rather than pixel predictions, which is a far less computational demanding operation. The codebook approach was used by Meta's Yu and colleagues to build the large language model known as Chameleon, which can handle an image codebook. Casual Mask Multimodal Modeling, a predecessor program that fair began the year before, is expanded upon Chameleon. It is a transformer-style program like ChatGPT that has been taught to anticipate the next element in a sequence, a decoder-only transformer architecture, but it also combines that with masking parts, or what is typed like Google's BERT program. The ability to program to phone home, if you will, to search through a database of documents that pull out any documents that might be relevant for the output of the program. It's referred to as retrieval, which is essential in big language models. It's a method for memory access so that the neural network's weight on parameters don't have to store all the information needed to make predictions. The first multimodal model built with a recipe adapted from text-only language models is called Chameleon. It consists of a large-scale retrieval augmented pre-training stage and two multi-mask supervised fine-tuning SFT stages. Yu and his team asserts that their database is a vector databank that can be searched for both picture and text content. Instead than using online images as a training dataset, the researchers instead make use of a database of 7 million licensed images from the stock photography business Shutterstock. The Shutterstock images are taken from a database and used in the pre-training stages of Chameleon to develop the program's capabilities. The pre-training procedure is the same for major language models like ChatGPT. The model is then refined further during a subsequent stage called Supervised Fine-Tuning, or SFT, in which the input and output of the pre-trained Chameleon are both fed back into the model. Microsoft Coco Captions, developed by Xinlan Chen of Carnegie Mellon University and colleagues and published in 2015, serves as a dataset used for their major test. The efficiency with which a computer duplicates images in the dataset is measured by what is known as a FID score. Recently, there has been an increase in the creation of generative AI models that can produce graphics from text cues. Models like Midjourney, DALL-E 2, and Stable Diffusion can be used to make photorealistic landscapes and portraits. These models use a technique called diffusion, which successfully reduces noise in a picture made entirely of noise and incrementally moves it closer to the target. Although diffusion-based techniques produce good results, they can be expensive to run and frequently lack the speed required for real-time applications due to their high CPU requirements. The tactics employed by Chameleon vary. It uses attention techniques to evaluate the utility of input material, including text and visuals, because it is a transformer-based model. Chameleon's distinctive architectural layout makes it superior to traditional diffusion-based methods in terms of parallelization and training speeds. Chameleon successfully trains on a dataset of authorized images using a single TPU pod, and then obtains a FID score of 4.88 on the MS Coco dataset. Researchers found that the model performs better than equivalent transformer topologies by a factor of over 5. Where Chameleon really shines is its capacity to handle more challenging demands in picture editing tasks. Chameleon, for instance, can accurately recreate an image given a prompt like a small cactus wearing a straw hat and neon sunglasses in the Sahara Desert. The model also performs exceptionally well when given free-form language instructions to alter pre-existing images, such as changing the color of the sky or adding objects in certain locations. These abilities much surpass those of current top models like DALL-E 2. To produce Chameleon, the flexibility and power of autoregressive models are merged with the efficiency and economy of training and inference. Since the CM3 model can generate text and image sequences based on any given text and image sequence, it complies with the requirements for casual mass mixed modal model. Compared to earlier models that could only perform one of these tasks, this is a huge advancement. Chameleon can simply switch between tasks including text, photos, and composition thanks to its versatile architecture. In addition to text-to-image translation, Chameleon can also make images from textual descriptions of segmentation maps and bounding boxes, and answer questions about the content of images. This combination of modalities into a single model is exclusive among known publicly accessible AI systems. The model uses a decoder-only transformer architecture, which is similar to well-known text-based models, but it can also handle images in addition to text. Training includes improving retrieval, utilizing the most recent scientific findings, and tailoring instructions across various picture and text-generating jobs. Chameleon Performance in picture captioning, visual QA, and text-based editing were all significantly enhanced by Meta utilizing a technique called supervised fine-tuning across modalities. Despite only having been trained on 3 billion text tokens, Chameleon matches or beats the outcomes of other models trained on as much as 100 billion. To produce Chameleon, the flexibility and power of autoregressive models are merged with the efficiency and economy of training and inference. Since the CM3 model can generate text and image sequences based on any given text and image sequence, it complies with the requirements for a casual mass mixed modal model. The researchers show that Chameleon can handle tasks like image caption generation, visual questioning answering, text-based editing, and conditional image generation substantially better when large-scale multitask instruction tweaking is used for both picture and text synthesis. The company published a blog post introducing Chameleon and distributed a white paper outlining the technological breakthroughs of the product. It was unclear from Meta when or if Chameleon will be made accessible to the general public, but Meta's research represents a significant step forward in the creation of multimodal models that can generate both text and images. Over the past few months, Meta has made a number of generative artificial intelligence tools available across all of its platforms, such as AI-generated stickers for Messenger, an AI sandbox for Facebook's advertisers, and a tool for making AI-generated films. This model, however, increases the bar for multimodal AI and shows the value of techniques like retrieval augmentation and supervised fine-tuning. It's a remarkable achievement that points to a future in which AI systems will be able to smoothly flip between understanding, editing, and producing text, video, and images. That's all about today's video. If you like this video, don't forget to like and subscribe to our channel. Also, press the bell icon to get notified of our upcoming videos. Let us know your opinion in the comment section below.